So isosceles triangles, we know some things about them already. We have some vocabulary to talk about with them. If we have an isosceles triangle, okay, the two congruent sides, we call these the legs. The two congruent angles are called the base angles. And then the side that's not congruent to anything else, that's the base side. And then the angle that's not congruent to anything else is the vertex angle. So we have some theorems to go with our isosceles triangles. The first one is if the two sides of a triangle are congruent, then the angles opposite the sides are also congruent. What does that mean? Well, if we look at an isosceles triangle, okay, if this side is congruent to this side, then they're opposite angles. And opposite means across from, right? So this angle here and this angle here are not across from this side. This angle is across from this side, right? You can sort of draw an arrow to it. So that means that the opposite angles are also congruent in an isosceles triangle. And there's the converse of that, which essentially says if we know that the angles are equal, then we can say that their opposite sides are also equal, right? So just the converse of the first one. We know some things about equilateral and equiangular triangles too, right? All sides are congruent and all angles are congruent. And we have some corollaries, right, that draw right off of that. First of all, if a triangle is equilateral, then it is equiangular. So the idea that if it's got all equal sides, it also has all equal angles. And then another corollary is the reverse of that, the converse, right? If a triangle is equiangular, then it is also equilateral, okay? So we know that both are true about equilateral triangles, but when we're doing a proof, it's good to have these proofs so we can jump right from the sides to the angles and so on and so forth. So we're not going to rely on something like definition of equilateral triangles anymore. We're going to use these corollaries to say, okay, if the angles are equiangular, then it's equilateral triangle. If the angle is equilateral, then it's equiangular triangle. And we can jump right from definition. We can say, okay, it's equilateral. By this corollary, it's also equiangular. Okay, it's equiangular. By this corollary, it's also equilateral. So we have a way of saying that now in our proofs.